I welcome you to the physics chapter 1 electricity. So, the people who don't know me, who don't know my channel, I'm Arihaan Sharma and I've started a new channel, a tutorial, like for the 10th class student who are really in burden and are actually thinking to join some coaching or like giving expensive fees to the coaching institute. I'll make you understand all the concepts very easily. Trust me, it's not hard. So studying is really never hard. Okay, so let's start. Physics chapter 1, electricity. So what is electricity? Electricity is an important sources of energy, right? In the modern times, because in previous times we didn't have any electricity quite much. We were really uh, so forget it. So let's start. So like have you ever done an experiment that if you rub your comb to your hair and then you bring near to the tiny paper pieces and the paper pieces begin to attract? So what is that? It's actually the charged comb which attracts that uncharged paper. So there are two types of electric charge. I'll write down here if you want to note, so you can note. Okay, there are two types of charges of charges. Okay, one is opposite charge and second is similar charge. So what is opposite charge? Actually, there are friends about. Have you ever seen in the magnet that the North Pole attracts the South Pole? So if the case is like that. Like there are actually positive and negative terminal. So they attract each other. The positive attract negative. Okay. And in similar charges, they are enemies. Similar charges means like positive will repel, as in the case not will repel. So you can relate to that. Okay. So, uh, I told you about positive charges and similar charges. So if we actually get to the point that the charge, so the SI unit of charge is SI unit of charge is coulomb. Okay. So it's really easy. Okay? The SI unit of the charge is coulomb. So okay, we get to the point. But now, like if we are talking about charge, there should be electrons in it, right? Electrons should come in it. So we will think that in one electron, how much charge is there? So the question or the answer to it is 1.6 into 10 raised to the power minus 80 minus minus 80 minus 19. Okay. Sorry, I don't have that software to like minus and 19 properly. So really sorry about that. Okay. So now actually it's a theoretical part. How it came? So to actually to consider that point, we ought to think it that it's true. Okay, and as it is a fact. So we know that in one column, in actually in one electron, we have 1.6 and 10 to the power minus 19 charge. Okay, so how much electrons are there in one column? Have you ever think that? Have you ever? So we actually know the answer, right? So why it actually? So we'll think that 1 divided by 1.6 into 10 raised to power minus 19 into 1 into 1. Okay. Then the game will totally change. Then it will become 10 raised to the power minus sorry 10 raised to the power 19 divided by 1.6. Okay. Then the finally answer would come 6.25 into 10 raised to the power 18. Okay, 6.25 into 10 to the power 18 electrons are there in one coulomb of charge. So, this I think the question is clear. If anything you have any doubt, I'll give you my email address. Like, I'm not talking about the questions, difficult questions. I'll also try to clear your all difficult questions, right? But if you have any doubt, like till this stage, so you can mail me at. I'll give my email address in the description. Okay. So the thing now the next concept we're going to start. Everybody, I think everybody knows about it. That like everybody knows about it. That is conductors and insulators. Conductors and insulators. Okay, everybody knows about it. Nothing is new. There's a simple definition for it. Right? Those substances, those substances which uh, allow electricity to pass through them. Electricity pass through them are known as conductors. And I'm not writing for insulators because now I think you have got point. Insulators were substances which do not allow electricity to pass through them are known as insulators. I'm not telling the bookish definition because I think it's a common thing. Everybody can write it in their own words. Okay. So everybody knows how a wire looks. Like there are actually the copper wire is inside. Those are conductors, and the outside covering, which is plastic, that is insulator. Okay. So now we are actually going to start with some actually like a tricky subject. I mean, there's a tricky concept, which is potential difference. Potential difference is actually first I'll tell you the formula of it. Okay, how to find it. Difference. So the formula is V is equals to W divided by Q. Okay. V is potential difference is equal to work done upon Q. Q is charge moved. Work done upon charge moved. So now you will get a clear picture. What is potential difference? Potential difference is actually the potential difference between 2 points in an electric circuit is defined as amount of work done upon charge moved in moving a unit of charge from one point to another. Okay, like I'll tell you the exact. I'll write an exact uh, definition here. The difference, potential difference between 2 points is in an electric circuit is defined defined as the work done to move an electric charge from one point to another. So again, we'll discuss that potential difference. Like I'll tell you the difference, the definition for the potential difference between 2 points in an electric circuit is defined as a work done to move an electric charge from one point to another. Okay, so like this is just a definition. It's for you to just learn it. You have if a question comes, you have to write the same. And in my experience, I have not seen that somebody will ask you the definition of potential difference. Okay, so the potential difference actually is, suppose you have one coulomb of charge. Okay, you have one coulomb of charge, and to move that one coulomb of charge from one point to another, and to move that one coulomb of charge from one point to another, you need some energy, like the work. There would be some amount of work done there. So the amount of work done there would actually, like, the amount of work done divided by the how much coulomb of charge is known as a potential difference. It's just known as a potential difference. Sometimes it's really tricky, but I don't think so now it's tricky, because I have told you that to move a column, move a charge. What is the SI unit? I told you SI unit of charge is coulomb. So move that charge from one point to another, some amount of work done is there. So that the work done divided by the charge moved is known as the potential difference. Like, sometimes you have seen that in the current rating of some electric supply, in rating, it is written as that 220 volt. So 220 volt is actually the charge moved from that point to that, from means from the powerhouse to your home to the point infinity. The amount of work done, some amount is worked, or the amount is done. Actually, what is also written, right? WATT. So divided by that, we get the potential difference 220 volt. Okay. So I hope that potential difference is clear. Now, electricity potential is actually the same thing. Like, the electric potential at a point in an electric field is defined as a work done in moving a unit positive charge from infinity to that point. What is a potential difference? Is that exactly the electric potential, but it tells you actually the system what we follow in a home, from the powerhouse to home, infinity to a home. Okay, so some numericals. I told you that we will do one numerical, right? So the question is the question is one. The people, if you're thinking that I'm just reading from the book and telling, no, actually I'm not doing that. I know all these things, but to make it more systematic and to make it more more convenient, I'm reading from the book. But I am also explaining what's written there. So it's a book, Lakmeer Singh, class 10th. It's really a good book. If you want to do physics, if you want to understand it properly, purchase this book as well as do it with NCRT, because board is totally based on NCRT. Okay, so and now I'll do it. So the question is question one. Okay, question one is, how much work done? How much work is done, okay, in moving a charge of 2 coulomb, okay, from a point at 118 volt, at 118 volts to 128 volts. Okay, so here you might be confused that I told you, that there's a formula. Okay, right? A formula would be applied. Which formula? V is equals to W divided by Q. So V is here, potential difference is equal to work done upon charge moved. Right? So, like, you might be thinking that there are 2 volts, 118 volts as well as 128 volts. So what do we take? So here actually, to find the actual potential difference, it would be 128 minus 118. The people who are thinking why we actually subtracted is this, because from a point, the point where the potential difference of 118 volt and point where we reached is 128 volt. Okay, so the potential difference is the difference between those 2 points. If you have not actually understood, I'll leave a link in the description. I'll tell you by writing. Okay, so it's 10 volts. Okay, so the potential difference would be 10 volts. Now we will apply just the formula is applied. It's actually 10 volts is equals to, now, work done upon charge moved. What is charge moved? It's two column. Okay, so here W is equals to, the work done is equals to 10 into 2. That is uh, W is equals to 20 joules. Okay, 20 joules. So we got the fact that W work done is equal to 20. Now I'll like the two sample problems. I'll not do the second one, because I hope that from the one question only you might have understood that how to do such questions. Such questions, I am telling you that electricity chapter is totally based on the formulas. Nothing is applied extra in it. No theoretical part is there. So now second, like very common thing, we have electric current. So what is electric current? Okay, like I anything which flows in a uniform direction is known as current, right? Like if water flows in a uniform direction, what do we say? Water current. And then the electricity which flows in the wires with a uniform direction, we say it as electric current. Okay, so it the uh, actually the exact definition, I'll tell you the exact definition. So electric current. Okay, so electric current is known as, it is the potential difference, okay, potential difference between the ends of the wire, which makes the electric charges flow in the wire. So the flow of current in the wire is known as electric current. I'm telling you, with the bookish language, like if anything comes out like this in exam, so you have to write the same. Okay, SI unit of current is unit of current is I. Sorry, it's actually means I. Means with ampere. I is, I'm telling you, is ampere, and we measure it. We measure with ammeter. Ammeter. Okay, so it's clear, right? We measure it with ammeter. Oh, I'm really sorry that this is spelling mistake. Right? We measure it with ammeter, and the SI unit of current is I. Means it's the symbol of current is I, and the SI unit is ampere, right? And now, okay, these are actually are the common thing. These are common things which everybody knows, but we didn't know. Like we know it that the SI unit is ampere, and we measure it with the ammeter. But do we know the formula that how to measure it? So that's actually I is equals to Q divided by T. where I is the current, U is the charge moved, and T is the time. Okay, so like a question can come, define 1 ampere of current. Okay, I'll write it. Define 1 ampere of current. Okay, so now 1 ampere of current. What you will say that 1 ampere of current is the current which is one. No. So we will define it as okay. So we will define it as when 1 coulomb of charge. I'm not writing it down, so please note it down. When 1 coulomb of charge flows through, when 1 coulomb of charge flows through any cross section of a conductor. Okay, again I'm repeating again. When 1 coulomb of charge flows through any cross section of a conductor in 1 minute, the electric current flowing through it is said to be 1 ampere. As I said minute, please change it to second. Okay, when 1 coulomb of charge flows through any cross section of a conductor in 1 second, the electric current flowing through it is said to be 1 ampere. Okay, and I've already told you that current is measured through the current is measured with ammeter. Okay, so now we get to the point, how to get a continuous flow of electric current. So the simplest way is to maintain a maintain a stable potential difference between the two ends of a conductor to get a continuous flow of current, and for that we use a battery. Okay, for that we use a battery because battery helps us to maintain a potential difference in a circuit. So to get a continuous flow of current in a circuit, we need to maintain potential difference through a battery. Battery, we actually everybody knows what is a battery, right? 1.5 volt battery which we use in our TV remotes and any memory. It's numerous things we use battery. So then the direction of electric current. So the conventional direction of electric current is from positive terminal. This is an important point we need to write. Conventional current, conventional current, the conventional direction of current is from positive to negative. What does it mean actually? The current moves from positive to negative. Okay. As I told you that there are two types of charges, opposite and similar charges. We did in this starting session right here, right? Opposite and similar. So, like, are we able to get it right? So this actually states completely from positive to negative. So the current flows from from positive to the opposite current. That's negative. Is that clear? Yeah, that's clear. I think. If any doubt, I'm again repeating again. If any doubt is if there's any doubt in any concept, please mail me. I'll give you my link in the description. Okay. Yeah. So like, it's a thing that how the current flows in a wire. That's right, that's a thing to be asked. How it flows, right? So I told you that it moves from positive to negative. Now I also told you that what are conductors and insulators. In a conductor, suppose in a conductor, the electric current always flow in a metal wire in the conductor. Okay, so it actually moves opposite to the conventional current. Like the electron flows opposite to the direction of the conventional current. That means that these electrons move from these electrons from the negative terminal move to positive terminal. In a battery, the electrons from the negative terminal moves to the positive terminal, and the conventional current in the positive terminal move to the negative terminal. That's a bit confusing, but listen it very peacefully. Open a like if there is a diagram of a battery, right? Then you would be able to understand it very properly. Okay. So what I'm saying is that in the negative terminal there are electrons. We know that. So when that battery is connected, that those electrons move from move to positive terminal. That the electrons in the negative terminal moves to positive terminal. Okay, and positive terminal has conventional current. So that conventional current in the positive terminal moves to negative terminal. Okay, is that clear? So this is how the current flows. So it's reversing it, potential difference is maintained here. So now we have electric circuits, right? uh, I sorry, I cannot draw symbols for electric components. It's actually given in your book, so please open that and so read all those components, like also learn them by heartedly. You should be able to you should be able to draw these components, because in this chapter not only formulas are there, but also you have to make these electric diagrams, which are not at all hard, so don't panic with that. Okay, so we have circuit diagrams. So how to draw a circuit diagram is that in every circuit diagram, one common thing is one common thing which is there every time. That is just a second, I have to write this. In a circuit diagram, one common thing one common thing actually battery. Okay, so a question can come. So which device is used to maintain the potential difference in an electric circuit? Okay, so here potential difference, to maintain a potential difference in an electric circuit, what do you need is a battery. Okay, yeah, a question can also come. So that which device is used to maintain a potential difference? So answer is a battery. So what I'm saying that in a circuit diagram, in each and every circuit diagram, which is a working circuit diagram, we have one common thing which is every time there. Without that, a circuit diagram cannot work. It's a battery, right? In a circuit diagram of like big things like your phone, what is a battery? It's the power out, the electricity coming from powerhouse. That's a source of battery, right? Then we have in a normal circuit, uh, we have a battery, right? 1.5 volts, 6 volts, 12 volts. So with that battery, what are connected? Wires are connected. Okay, in a circuit diagram, wires are connected. So to actually look at that, as I said, I cannot discuss these electric components because it's really hard to make in this notepad. So I'm not making it, but I will tell you, right? So the wires are there. A switch would be there. Obviously, you need to open and close that circuit. So for that you need a switch. So when you will learn these components, you will know that what a switch looks like, what a bulb looks like, what a battery looks like. So we actually need to connect these. We actually need to connect these in actually a rectangle type some shape. And always actually it's really you have to learn this, a thing in circuit diagram which is known as resistor. There's some resistance in that circuit. Resistance means that it will oppose the flow of current to, to some extent. High resistance will oppose much and low resistance will oppose low. So resistor is when you will learn these components, you will see that resistors are like you will learn the shape, right? So voltmeter is actually voltmeter meter is through which we calculate potential difference. Okay, voltmeter is through which we calculate potential difference. So voltmeter, to calculate the potential difference, you need to keep in the mind that voltmeter is always connected in parallel with that resistor. I'll tell you about what is how to connect in parallel and how to connect in series, right? But when you will learn these electric circuit diagrams, as we're not doing it, I'm really sorry for that. When you will learn these diagrams, you will know how to connect it in parallel. And the ammeter, which I told you is a device to calculate the current, is always connected in series with that resistor. Okay, so now we get to a point, like we get to another concept, what is known as Ohm's law. Ohm's law is actually a kind of law. It's kind of a law which was actually means it was a law that proves that at constant temperature the current flowing through the electric circuit is directly proportional to the volt to the potential difference, right? What I'm saying is Ohm's law is that at a constant temperature temperature the current flowing in the electric circuit is directly proportional to potential difference. So a question can come you in 1 marks also and in actually a part of 5 mark question that state Ohm's law. So a simple thing is that at a constant temperature the current flowing in the electric circuit is directly proportional to the potential difference. Okay, sorry I'm for the spelling mistakes. Okay, the formula is equal to V is equals to I into R. Okay, that potential difference is equals to current into the resistance. Resistance, I told you that resistance is uh, that opposes the charge of the flow of current at some extent. Okay, and the current is also inversely proportional to the resistance. Keep it in mind. I have told you the formula that V is equal to I into R. So now you can see clearly that that potential difference is directly proportional to I, and this case or this law is only applicable when it is kept at a constant temperature. Okay, V is equals to I into R, and also you can see that I is indirectly proportional to the resistance. So that's okay, okay. And V, that potential difference, is also directly proportional to the resistance. Okay, okay. So now we actually have a proper topic of resistance. What is the property of a conductor due to which it opposes the flow of current? It's called a resistance, which I told it's just a bookish definition. I will not take it much, right? Now, we Ohm's law, we have some numericals of it. Okay, uh, numerical. I'll not write. I'll just dictate the numerical. If you want to write, you can write the numerical. Okay. A simple electric circuit has a 24-volt battery and a resistor of 60 ohms. What will be the current in the circuit? The resistance of the connecting wires is negligible. Negligible means that the resistance of the wire we have to take 0. Okay. So we know the formula. We know this formula, right? V is equal to I into R. So what we are going to do, we are just using this formula. What we have given, that potential difference is 24 volt. Okay, and resistance of of 60 ohms. The SI unit of resistance is ohm. 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 And then we need to find the we have to find the current. So it's damn easy, right? 24 is equals to I into 60. We'll get I is equals to 24 divided by 60. And what we'll get, I is equals to, we'll get that it is 6 divided by 50. Okay. Then like when you will change it into the decimal form, then it would be I is equals to 0.4 HMS. Okay, so it's a simple thing, right? In actually, like in most what I'm telling you is that I will not, not take it to the much because in this lesson I'm teaching you about what is this concept actually. I'll solve all the difficult means I'll try to solve all the difficult questions in a specific video after completing this chapter. And and I'm really sorry to tell that it's a part 1. We'll continue the part 2 tomorrow. So before ending this lesson, I'm going to give you actually what I told you, that we know, right? We know that uh, what we know uh, potential difference is always directly proportional to the current in a given circuit at a constant temperature, right? So I'm gonna give you a graph which will prove the same. Just, okay, as you can see, let's see this one. This is voltage, this is current. As you know, it's directly proportional. If it will, the current will increase, the voltage will also increase by the same ratio. So there would be a there always will be a straight line, voltage, current, and a straight line. Okay, this is the graph I want to tell you. So thank you for seeing this video, and if you like this video, give a big thumbs up. And like if you have any doubt in any of the concept, I'm leaving my mail email address at the description. Please please mail me all the doubts, conceptual doubts, as well as some of the questions. Like now, not now. Don't mail me the questions now. I'll take it. I'll tell you when to mail those questions, but you can mail me the conceptual doubts right now and tell it actually spread this channel to all of your friends because uh, I'm telling you because in 11th class, trust me, you will spend lakhs of money in your coaching. So please don't waste money in 10th class. And all the best for your board exam. I'll do. I know you will do very well. Okay, thank you. And please subscribe my YouTube channel. Do if you liked it. If you think that your doubts have been cleared. Thank you.